Understanding how IP addresses are organized and divided is a fundamental skill for anyone working in cybersecurity or network administration. You have already explored ports, transport protocols, and packet capture with tools like Wireshark and Nmap. Now it is time to go one layer deeper and understand how networks themselves are structured through a system called classless interdomain routing, commonly abbreviated as CIDR. This lesson explains what CIDR is, how to read and write CIDR notation, how subnetting works, and why it matters in a security and DevSecOps context. Before diving into CIDR, let us recall what an IP address is. An Internet Protocol version 4 address is a 32-bit number written in 4 groups of decimal digits separated by dots, for example 192.168.1.10. Each group, called an octet, represents 8 bits and can range from 0 to 255. The full 32-bit address uniquely identifies a device on a network. However, not every bit of that address describes the device itself. Some bits describe the network to which the device belongs, and the remaining bits identify the specific device within that network. Understanding how many bits belong to the network versus the device is the core idea behind subnetting and CIDR. Historically, IP addresses were divided into fixed classes: Class A, Class B, and Class C. Class A networks use the first 8 bits for the network and the remaining 24 bits for devices, allowing enormous networks with millions of hosts. Class B networks use 16 bits for the network and 16 for devices. Class C networks use 24 bits for the network and only 8 bits for devices, meaning a maximum of 254 usable host addresses per network. This rigid system wasted enormous amounts of address space because organizations were forced to take an entire class even if they only needed a fraction of it. CIDR was introduced in 1993 precisely to solve this problem by allowing network boundaries to fall at any bit position, not just at 8, 16, or 24. CIDR notation expresses an IP address together with the number of bits used for the network portion, written as a suffix after a slash. For example, 192.168.1.0 out of 24 means that the first 24 bits identify the network and the remaining 8 bits identify devices within that network. The number after the slash is called the prefix length or subnet mask length. It can range from 0, the entire address is a host portion, practically representing the entire internet, to 32. All 32 bits identify a single specific host. To fully understand CIDR, you need to understand the subnet mask. A subnet mask is a 32-bit number where all the network bits are set to 1 and all the host bits are set to 0. For a /24 network, the subnet mask in binary is 111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111which translates to 255.255.255.0 in decimal notation. For a /16 network, the subnet mask is 255.255.0.0. For a /8 network, it is 255.0.0.0. For a /28 network, the subnet mask is 1111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111Let us go through a concrete example step by step. Consider the network 192.168.10.0 out of 24. The prefix length is 24, meaning 24 bits are for the network and 8 bits are for hosts. With 8 bits for hosts, you have 2 raised to the power of 8 equals 256 possible combinations, ranging from 0 to 255. However, 2 addresses are always reserved. The first address, all host bits set to 0, is the network address, and the last address, all host bits set to 1, is the broadcast address. So in 192.168.10.0 out of 24, the network address is 192.168.10.0 and the broadcast address is 192.168.10.255. The usable host addresses are 192.168.10.1 through 192.168.10.254, giving 254 usable addresses. Now consider a smaller network, 10.0.0.0 out of 30. The prefix length is 30, leaving only 2 bits for hosts. 2 to the power of 2 equals 4 total addresses. Subtracting the network address and broadcast address leaves only 2 usable host addresses. The network address is 10.0.0.0. The usable hosts are 10.0.0.1 and 10.0.0.2, and the broadcast address is 10.0.0.3. A /30 network is commonly used for point-to-point links between two routers, where only two addresses are needed. The formula to calculate usable hosts in any subnet is 2 raised to the power of 32 minus the prefix length, then subtract 2. For a /24, 2 caret 32 to 24, 2 equals 2 to the power of 8, 2 equals 256 to 2 equals 254. For a /25, 2 caret 32 to 25, 2 equals 2 to the power of 7, 2 equals 128 to 2 equals 126. For a /26, 2 caret 32 to 26, 2 equals 2 to the power of 6, 2 equals 64 to 2 equals 62. For a /27, 2 to the power of 5, 2 equals 32 to 2 equals 30. For a /28, 2 to the power of 4, 2 equals 16 to 2 equals 14. For a /29, 2 cubed, 2 equals 8 to 2 equals 6. Subnetting is the practice of dividing a larger network into smaller subnetworks. This is directly relevant in security work. For example, if you are performing a reconnaissance scan with Nmap on an authorized perimeter, knowing the CIDR notation of the target network tells you exactly which addresses to scan. A target described as 10.10.10.0 out of 24 means you will scan up to 256 addresses. A target described as 172.16.0.0 out of 16 means up to 65,536 addresses. Misreading the notation could mean scanning too broadly, which is illegal outside authorized scopes, or missing hosts entirely. Let us also look at how CIDR aggregation works, because you will encounter it when reading routing tables or firewall rules. CIDR allows multiple contiguous networks to be summarized into a single notation. For example, the four networks 192.168.0.0 out of 24, 192.168.1.0 out of 24, 192.168.2.0 out of 24, and 192.168.3.0 out of 24 can be summarized as 192.168.0.0 out of 22. Why? Because a /22 network has 10 bits for hosts, 32 to 22 equals 10, giving 2 to the power of 10 equals 1024 addresses, ranging from 192.168.0.0 to 192.168.3.255, which exactly covers all 4/24 blocks. This aggregation is called a supernet and is used to simplify routing and firewall rules. The concept of private address ranges is also closely tied to CIDR. Certain CIDR blocks are reserved for private use, meaning they are not routable on the public internet. These private ranges are 10.0.0.0 out of 8, covers 10.0.0.0 to 10.255.255.255, over 16 million addresses. 172.16.0.0 out of 12, covers 172.16.0.0 to 172.31.255.255, over 1 million addresses. 192.168.0.0 out of 16, covers 192.168.0.0 to 192.168.255.255, about 65,000 addresses. These are the ranges you will consistently encounter in local networks, virtual machine environments, Docker container networks, and Kubernetes clusters. When you set up a DevSecOps pipeline with containers, the container orchestration system assigns addresses from these private ranges. Understanding where a given IP falls helps you determine whether you are dealing with internal traffic or external traffic, which is critical for threat modeling and access control policies. One special CIDR notation worth knowing is the /32 prefix. A /32 means that all 32 bits are the network portion, leaving 0 bits for hosts. This represents a single, specific host address. In firewall rules, you write 192.168.1.50 out of 32 to mean exactly and only the host 192.168.1.50. Conversely, 0.0.0.0 out of 0 is the default route, representing all possible IP addresses, and it is used in routing tables to mean send traffic here if no more specific route exists. Another important example: if you capture traffic in Wireshark and see packets coming from 172.16.5.33 and going to 172.16.5.255, you can immediately recognize that 172.16.5.255 is likely a broadcast address within a /24 subnet, 172.16.5.0 out of 24. Seeing large volumes of traffic toward a broadcast address can indicate network scanning activity or a misconfigured device, both of which are relevant security signals. For penetration testing and reconnaissance, understanding CIDR is essential when interpreting scope documents. Authorized testing scopes are always defined in CIDR notation. For example, a Rules of Engagement document might state the authorized scope is 10.200.0.0 out of 20. A /20 means 32 to 20 equals 12 host bits, so 2 to the power of 12 equals 4096 total addresses, from 10.200.0.0 to 10.200.15.255. If you accidentally scan 10.200.16.0 and beyond, you are outside scope, which is a legal violation. Correctly calculating the range is therefore not an academic exercise but a professional and legal requirement. To summarize the key facts you must retain from this lesson. CIDR notation combines an IP address with a prefix length, for example 192.168.1.0 out of 24, to define a network block. The prefix length indicates how many bits identify the network. The remaining bits identify hosts. The subnet mask is the decimal representation of a binary number with all network bits set to 1 and all host bits set to 0. The number of usable hosts in a subnet is calculated as 232 minus prefix length, minus 2. The network address, all host bits at 0, and the broadcast address, all host bits at 1, are not assignable to individual devices. Private address ranges, 10.0.0.0 out of 8, 172.16.0.0 out of 12, 192.168.0.0 out of 16, are not routable on the public internet. A /32 identifies a single host, a /0 identifies all possible addresses. CIDR subnetting directly impacts how you scope Nmap scans, write firewall rules, and understand packet captures in Wireshark. Misreading a CIDR notation in a penetration test can mean scanning outside the authorized perimeter, with serious legal consequences. Mastering CIDR and subnetting gives you a precise and professional understanding of network boundaries. Whether you're analyzing traffic captures, configuring firewall allow lists, setting up secure container networks, or reading a penetration test scope document, this knowledge is not optional. It is the foundation on which all network security work is built.